So solving systems is all about finding out where two lines meet or more than two lines. So if you do it by graphing, you graph a line, you graph another line, and then wherever they meet is the solution. So, you know, I like to always show all the different methods. And some people are really good at one method and they can't do either of the other. So we have to be able to do all the methods. But, you know, and me graphing a line here is going to be really bad, but I'm just going to make this up. You know, so let's say this is line 1, and then you're given another line, and, you know, they don't have to be perpendicular, but let's say you have another line that looks like this, hopefully straighter than mine, and then you say, what's the solution? And you say the solution is 1, 4, because that's where they meet. Does that make sense on the graphing? So if you can graph a line, because you're going to have to be able to graph 2 lines now. But if you can graph a line, you should be pretty good. How is my internet today? Is it better? No. Ugh, so annoying. As I asked that, the thing popped up and said, your internet connection is unstable. I was in a meeting all Friday afternoon, and you'd think that Friday afternoon people are out doing stuff. But from 1 to 4:30, I had poor internet connection. I don't know. I might have to talk to my provider. Okay, so if that makes sense, then I'll show one by substitution. I have to move stuff around. Let me try to make some space. So when it says solve by substitution, then you use another method. And this is where you need to first isolate one variable. I don't care which one. So let's look at this. I'm going to play with this a minute, and you have to make good decisions. That's what this is all about. Like, if you make a bad decision, it's not bad, it's just confusing. So what if I said, oh, well, I have to isolate one variable, and don't write this stuff down. 2x plus 3y is 10. What if I said, hey, I'm going to isolate this x here because I feel like it? That means I have to do the following. You know, you'd get rid of this term. Then you have to turn around and divide by 2. And then 10 divided by 2 is 5. So you could do it this way. You could use any variable you want, but do you see how you created a fraction and it looks messy? And this is called substitution. So you would then take this piece and substitute it into the other equation, you see? But if you plug that into here, it's not a big problem, but most of you don't like fractions, and then you have to clear fractions and you have to do a ton of work. So this is where you make a good decision. You want to say the easiest one, you know? And easiest, I mean, easy to you might not be easy to me, and I understand that that is a little bit subjective, but I think we can all see, and sometimes you just play with it and then you decide to change your mind, but is it not the easiest thing if you took this equation and you said, I'm going to get that x by itself? You see? That's the easiest thing I can do. I can move that y and isolate the y, and I understand you guys are kind of trained in chapter 3 to do that y equals mx plus b, you know, so you're always isolating the y. You don't have to. When you're substituting, you're simply looking for the easiest one to isolate. And in this case, it's that x here is the easiest one because all you have to do is add y. Then you take this. This x is now going to be substituted into the other equation. So this piece here goes where that x was. So the steps are isolate one variable, and then you are going to substitute that, whatever that is, into the other equation. So in this case, we have 2x plus 3y is 10. Now you're going to say that x is a y plus 5 because it's right there. See? That doesn't change. You still have to continue with this equation here. Then you say plus 3y is 10. So all you've done is you've replaced that x with this piece. And then you just distribute and solve. The whole idea is now you have only, in the beginning, you had two variables. You see this, x and y, and here you have an x and a y. When you have two variables, you can't really isolate and solve for a specific variable. But look here, now we have 2y plus 10 plus 3y is 10. Do you see how now we have only one variable, the y's, and now you can solve. That was the whole idea. Now we're going to combine like terms. This is basic math. This is a little weird because when you subtract the 10 over, you get a 0. Is this a problem? Not at all. 0 divided by 5 is 0. And then what do you do with this? You plug it into the other. Now I'm gonna do, this was a step. Oh, my internet connection's unstable. Arg. So now you plug what find, right? Oh, I have here, I should have said this. On number 2, solve, right? That's what I did here. And then you plug what you find into either original. So this isn't pretty, but whatever. So which one should I plug it into? I'm going to plug it into the one that's smaller. So the y is 0, so x minus 0 is 5, so x is 5. Now, my solution should be 5, 0. Now, what if I made a mistake? Because I'm distracted, my internet isn't working, I'm listening to Barney in the background, and you guys, you know, everybody has stuff going on. What if I'm wrong? So why should I not check, you know? Oops, plug what find into either original. Hang on a second. You see, solve again, you know. You know, you're going to solve for the remaining unknown variable, whatever. And then you have your ordered pair, and then you're going to check. You should check it in either original. So this is how they'll ask you to check, and then I'll show you what else you could have done to check. 5, 0. So you have 2 times 5 plus 3 times 0 equals 10, question mark? So 10 plus 0 equals 10, that's true. And for it to truly be, definitely be true, 100% sure it's true, you have to check it in both. Because this here just means that that first line goes through 5, 0. So we're going to also check the other one. 5 minus 0 is 5, also true. Yes? Chase, did that help at all as far as how to approach it?
Yeah, makes a little more sense.
Okay, and then it's always a struggle, which one do you pick? You know, so let me play with this again. And one other way to check this, as far as, you know, you found a 5, 0, instead of plugging it into either, you could graph these two lines and see if they meet at 5, 0. You could do the addition method that we're going to learn here in a few minutes. So you have options. Once you know all the methods, you can use a different method to check your work. But what if I'd used a different one? Let's say I'd said, hey, I'm going to isolate that y, you know, because you guys are used to y equals mx plus b. Do you see how if you subtract that x, and I'm going to let the x lead, and then you divide by -1, divide by -1, divide by -1, or you can say multiply each term by the -1, and you get y is x minus 5. You could do it that way. And then you could plug it into the other one. Let's see what that looks like. 2x plus 3 times y is x minus 5 equals 10. See, this time you'd be solving for the x's. Don't forget to distribute. Let's see if we get the same thing. 5x minus 15 equals 10. Plus 15 plus 15. And x is 5. And then when x is 5, you plug it in. And you subtract 5, so you get negative y is 0, so y is 0. So do you see how it doesn't matter which one you isolate, you're still going to get the same answer. Excuse me. Calvin Moss? You have graham crackers. Oh, wait, I forgot. Sorry, I forgot to give my child his graham crackers. Come here. Don't drop them. This is not distraction-free environment, folks. But we'll manage. Okay. So do we want to look at how to do it by addition? Do we want to graph one? What do you guys want? Communicate. Tell me what you want to work for you.
I have a question. I did it on my homework yesterday and I was trying to find the problem, but it was basically something like 2x plus 3y equals, I don't know, or I don't know how to explain it. Trying to find the problem.
So the best thing, Markeisha, is when you're in the problem, you click on the Ask Instructor. Hopefully I didn't break up, but when when you're in the problem, click the Ask Instructor and it'll shoot me the link and then I can work it. I can also then bring it into this kind of a setting and show it.
Yes.
So,
okay. All right. I found it.
Okay.
Okay. It was 3x plus 2y plus 5 equals negative 10 plus 7y minus x.
And what is, okay.
The next one was x plus x equals y plus 3.
Y plus 3?
Yes.
And this is a substitution?
Yes.
Okay, very good. So before, on this type, okay, you have options. You always have a lot of options. That's the struggle with this. But you could, okay, so on this first one, I've done this before many times in class where I try one way and then my natural instinct tells me that I want to move all those x's together and I want to move all those y's together before I do anything. But I'm going to tell you, in this case, I believe it's better if you leave it alone, the first one. Let's look at the second one. Line 2, x plus x is 2x, yes? Do we all agree that I could isolate this y? That's the easiest thing I could do to isolate a variable. So I'm going to isolate this y by getting rid of that 3, yes? So I have a y equals 2x minus 3. And again, you can do this 5 different ways. You really can. It's just that's what I choose to do, the easiest thing that I can possibly figure out. So if y is 2x minus 3, and then you're better off not fiddling with line 1 and moving stuff around, you're better off just bringing this y into these places. So we're going to replace those y's with this piece. That's called substitution, yes? So let's try that.
Yes.
3x plus 2 times y is 2x minus 3. So this is where it's critical. You got to use parentheses so you can then distribute. Plus is negative 10 plus 7. Y happens to be 2x minus 3 minus x. And then we'll distribute. It's kind of messy looking, but you're really better off, in my opinion. You can do it the other way where you move all the y's and x's to one side. But I'm going to stick with this for now and see if it works for me. 4 times 2x, -6. Catch me if I make a mistake. I've not slept real well. My son got up late. And I make mistakes just like any human being. But I try to fix them before it's too late. 7x, now you want to combine like terms on each side. -6 plus 5. So this is, a lot of students have trouble with basic math. They struggle with basic math and then they fail in this class, even though they could be good at algebra. Now, I know it seems silly. You can use a calculator. You know, I don't care. But if I always say, use the checkbook, like if you had pre-algebra, it depends on who you had as a teacher. -6 plus 5, here's how I teach it. Think about a checkbook. I have a balance of -6. I deposit 5, so I have a -1, yes? And when you're on the same side of the equation, that's when you combine, right? Combine like terms on that side. You don't move stuff across the lines. So yes, I put a lot of basic math in here as far as clarifications, because that's, I see it in the classroom. People really, really struggle. Now that 14x minus x is 13x, yes? Because that's a 1x. You know, just because you don't see a coefficient doesn't mean it doesn't exist. It's a 1x. And then you have a -10 minus 21. So this is where I say, okay, I borrowed 10 and I borrowed 21. That doesn't make it positive, because some students think, oh, 2 wrongs make a right, you know, negative. Like if I have a 5 minus a -3, these are two negatives together. But that's where I say, oh, these two make a plus. This is different than I borrow $10 and I borrow another $21. I owe 31. So it still says my internet connection is unstable. All I can do is apologize for my internet connection. It's gonna get frustrating. Can you all hear me okay? Yes?
Yes.
Okay, so let me know if things get ugly as far as you can't hear me, can't see me or whatever, and you might be better off not being able to see this morning. Okay, so now we have to move all the x's to one side. So how about if I move my x to the left, do you see how I have to subtract 13 and I get a negative? I'm gonna try to avoid that. So this is personal preference. You guys can do this however you want. But I'm gonna have a -1 is 6x minus 31. Then I'm gonna add 31. So I have a 30 equals 6x. Then I divide by 6, divide by 6. So I get x is 5. So you can do this different ways and it doesn't matter. Just figure it out or get with me, because that's a pre-algebra issue. If you have trouble from here to here, it's completely fixable. And you know, I had someone yesterday who was needing help and talked about hiring some tutor, and I'm like, well, I'm right here and we have a tutor who would offer to help, Miss Crawshaw. I think I shared that message. That's free. That's, you're paying for this. You need to use what you're already paying for. I'm very frugal and I don't like to waste my money. Okay, so x is 5. So then we have the original, and I need to make sure I don't look at my example, but at this one Markeisha gave me. I love it when you guys bring the examples. I'm going to use the line 2. X plus x is y plus 3. This is the line that was given. And I'm going to say, well, x is a 5 and x is a 5. And then I have a 10 is y plus 3, subtract 3, 7 is y. So your solution should be 5, 7. And then you would plug it into both of them and hopefully it's true. Markeisha, does that help at all?
Yes, it does. I'm doing like 3 of those last night, and each time I got with fractions. And so it was really frustrating.
Yeah.
So,
Yeah, and it's really, I don't know if you can figure out where that might have happened. I'm thinking maybe did you move all this stuff across first?
Let me look what I did. I ended, I tried to substitute, or yeah, I did the 2x equals y plus 3. And
Okay.
then I ended up, I ended up with divided by 2, and I got x equals 1
Oh.
half over y
And you
plus
see how
3
right here, if I had divided by 2 and divided by 2 and divided by 2, it's not a problem, but it's more difficult for you. So you can avoid that, right? By just isolating
Yes.
that y. So always choose the easiest way.
Yes.
If you get right here, hang on, I'm going to change color. If you get right there and you get some weird fractions, now sometimes, okay, over 2, 9/2, so whatever, or 7/3 is not the end of the world. But if you get some weird thing like 51/41 or something, it means you did something wrong somewhere. These should be pretty clean numbers. So as soon as you get something here that looks weird, you might want to go back pedal and say something's wrong. I need to fix it. Good questions. That's what I like to do. Like clarify. Yes, thank you. Bring questions. Shoot me a message ahead of time if you want, and then I can just bring up the screenshot, stuff like that. So I can really help, or I feel like I'm helping at least. Okay, so then do we want to look at addition while we're here? And this week is going to be a little rough. What do we have due? Chapter 4 and 9. Now, chapter 4, it's just solving systems. You're going to solve by graphing, by substitution, and by addition. And then you have chapter 9, which is inequalities. I have a special video on that one already. And it's at least that 8-minute video where I'm clarifying, you really, really need to watch that one. That's already available. Because I don't mind repeating myself. I do it every semester. But if you come prepared with that, then everything, I'm just here to clarify at that point. But I think I'm going to do another meeting Wednesday evening, we said, to those of you who want to show up. This is never mandatory. Somebody said, well, will I get in trouble? I'm like, no, because this is not mandatory. I'm just trying to help. This is kind of office hours, really, little tutoring, office hours, etc. I can't teach the whole class here, but although today we're kind of getting the major gist of it, we have enough time for that. Okay, so now it says by addition. In the old book, it called it elimination method, so it would have said solving systems by elimination. In this book, it says use addition. I'm going to tell you, think of it as a combo. Because if you do, these two words right here tell you exactly what to do. You're going to add these two lines. There's line 1 and line 2. You're going to add them together. But as you do, one variable has to eliminate, meaning it disappears. So look at this right now. Don't write anything down. But if I added these, if I just call it addition method and I immediately say I'm going to add these, look at this. 2x plus 6x is 8x. 5y minus 2y is 3y. 11 minus 1 is 10. How does that help me? Not at all. You have an equation with two unknowns you cannot solve. So the goal of this when you're solving is to get rid of a variable, just like we kind of did it in substitution too. And that just happens automatically. So what we're going to do is we need to, and this is a little hard to write down in the book. I don't always like the wording. What do we need to do first? First, we need standard form. And what I mean is that I don't care in this case if my leader is negative, but what you need is if you had a line that said y is 3x minus 8, and you have that line, you would have to make this standard first, moving that 3x over. So these are already in standard form, so you don't have to do that step 1. Step 2, this one's the hard one to write down. Your goal is to have exact opposites of one of the variables. So one variable, and in the book it'll say multiply each line to where one of the variables will eliminate if you add, pretty much. But you need one variable needs to be exact opposites. So let's look at this, because then you're going to add the lines. And one variable will eliminate. You see, that's the idea. You know, and then you solve. You don't have to write this down. I mean, I'm going to share this video if you guys want. And then we're going to solve for the remaining variable. Let's look at this. So right now, if you added them, nothing disappears. Now, then you have to choose. Which one do you want to eliminate, the x or the y? So let me show you both ways this once, and then we'll just decide which one we like better. If you choose the x's, what would you have to do? So if you choose the x's, actually look at this, and we're going to try both, and then we're going to decide which one would have been better, but because you have to make that decision every single time. If you multiply this line 1 by -3, you see, you would have, I'm going to write the first one in black, that one. I'm going to leave that one in black so we don't get confused. And then -3 times 2x is -6x. Do you see this now? Later, when you add them together, 6x minus 6x is 0x, it disappears. That's the goal. But here's the thing, we have rules in math. You can't just do that. If you do it to one, you have to do it to all. So in the book, it'll probably show a parentheses like this, or you could put a -3 by every single term. I like that better almost, because that way you don't miss, well, it's up to you. You know, where you distribute, you just do an arrow. I don't know how you guys like to work, but you're pretty much multiplying every single term in line 1 by -3. So you're going to have a -3 times 5y and a -3 times 11. Is this okay for you guys? Mm-hmm. I'm just watching your faces, trying to gauge on if this makes sense, you know, making sure that I'm getting through. Okay, so.
Where did you get the -3? Did you just guess?
I just made that up. Okay, so where did I find the -3? Gary? Okay, so.
Yeah, I just wondered if you were just picking a number, if you had that.
Actually, it's not a random number. So look at this. I'm going to write this down. If you choose to eliminate the x, so if you choose the x, the littlest thing, I could say I want, you know, my goal is to, when I add them, I want them to eliminate. So, sorry, I have baggage now. Here's my baggage.
Mom, there's a bug on you.
Yes, it's okay, honey. Okay, if you choose the x, you can do a bunch of things. You know, if you have a 12x minus a 12x, they would eliminate. But the easiest thing is, if you look at it, that you have that 6x right here. And then what's the easiest thing? If you multiply this by -3 times 2, then you get that 6x. That -6x right here. You see, this is line 2, and this is line 1. Calvin, you're going to have to let me do my job here.
I need to see the bug close.
Sorry, there's a bug on my screen. It won't bite you. Here, you go play with it. It's attracted to the light. So we're looking really silly here playing with our screen. Can you go watch Barney, please? Oh, my word. Keep your cool in the summertime. So this is why I chose -3. Does it help at all? I'm all over the place. This is not a good recording. Send this to the boss. So we'll talk about it here in a minute if we chose the y's. So Carrie, I think it'll make sense once let me finish this one, and then we're going to do the other one, and then everything will be clear. So you're going to add them. So this is step 3. 6x minus 6x is gone. Negative 2y minus 15y. So I borrow 2, I borrow 15, I owe 17, yes? And I borrow 1, I borrow 33, I owe 34, and this gives me hope. Look at this. 34 is evenly divisible by 17. Right there, I know that I'm on the right track. Watch your signs and stuff, but negative divided by negative is positive, and that should be a 2. Yeah? And then if y is 2, you plug it into either. Which one do we want to plug it into? And that's it. You have to make lots of decisions on these kind of problems. So I'm going to use the one with the 1 and not the one with 11. Is that okay for you guys? You plug it into either. So you solved, and then you plug into either and solve the other variable, you know, for remaining unknown. I know this is kind of, and my handwriting is not good. So 6x minus 2y is negative 1. That was one of the lines. 6x minus 2y is 2. 6x minus 4 is negative 1. 6x, I'm starting to worry just a little bit. I don't like these numbers, but that's just me. Plus 4 plus 4. So x is 3/6 and x is a half. Is that what you're getting? I need you all to help me because you have brains too. You know, you have more brain power than I do by myself. What we can do to check this is plug it into the original. I feel like I made a mistake, okay? So it's very possible that I made a mistake. I'm distracted.
Get off that channel.
A half and 2. And I'm going to ask because I do not know if it's true. So let's keep this in mind. Is there anybody who found that I made a mistake? Calvin, Schluss jetzt. Calvin. Oh, Lord. I want to try the other way to see if I get the same exact answer, but then my stuff will be gone. Kelvin, don't touch my computer, please. No. I should have asked Oma to help me, huh? You're usually so good, and I'll just set you up with a movie. Can't you watch a movie? No? You're not coloring right now. I'm working here. Maybe if you behave.
I am behaving.
Very good. Let me finish my job, okay?
Just sit down on my
Okay.
neck.
So I'm going to try the other. So I'm going to start over and try the other one. What if I choose the y's? Yes? So let's say I choose the y's. Do you see how I can't just multiply one of them and make it the exact opposite of the other? You see that, Carrie? If I multiply this one by, I'd have to multiply by a fraction, and that's not something we want to do. So can you see how you need some number that if you multiply them, they will eliminate? Do you see how a positive 10y and a negative 10y will eliminate? And that's why if you do it this way, you have to multiply both lines. That's why this way is probably easier, since you're only multiplying one line. So we're going to choose, I'm going to do this in a different color, in green. So if I want that, you see how you can also choose a 20 or anything that 5 and 2 both fit into, but the easiest one is a 10. So if my goal, this is my goal, is to have a positive 10y and a negative 10y, the nice thing on this is that these have opposite signs already. These ones here, the x's did not have opposite signs. So if you multiply this by a 2, you know, you have to distribute it through, but that causes 2 times 5y is that 10y you need. So 2 times 2x is 4x. 2 times 11 is 22. And then you have, does that make sense? I don't want to go so fast. Some people take notes, other people don't take notes.
And wipe the green off.
And then 5 times negative 2 causes that negative 10. 5 times 6x is 30x. 5 times negative 1 is negative 5. And then let's add them together. And this is actually me checking my own work because I don't like this answer here, that one that I found. So let's see what happens here. 4x and 30x.
I don't like that.
And 22 minus 5. So x is 14 over, this gives me a great hope it's not 14, 17. X is divided by 17, divided by 17, you see? Calvin, I need for you to wait, go watch Barney. And when you come back, you get to play on my computer.
Oh,
Oh, my word. So if this is a half and then I plug it into either, I'm going to assume I get a 2. Does this help clarify at all?